Here is the picture for parameterization of a surface in order to integrate on that surface. So we have the domain from which we're parameterizing, and we'll call the parameters S and T. And then we have the surface that we get as a result. This is a surface in R3, and it's oriented. We have a normal direction. Now what we'd like to understand is how to get the normal direction and a little patch of area from this parameterization. So we're going to start with the parameter space, and we have a little patch of length ds and dt in the parameter space. And then we'll see what happens to it under the parameterization sigma. So here's the picture. There's a little patch on the surface, this patch here on the surface. On this curve here is the curve that we get by changing t. So there's a little tangent vector to that curve, which is d sigma dt. And this curve here is the curve that we get by changing s. And so there's going to be a tangent vector to it, which is d sigma ds. Now, if the change in t is small, this length is going to be scaled by dt. And the same is true for d sigma ds. This vector is going to be scaled by the change in s. And now, so we have these two little vectors, and what we think is that the parallelogram swept, the parallelogram with these two vectors as its sides, has approximately the area of this little patch here. Now, what about the normal direction? Well, the normal direction is perpendicular to the surface, and these two vectors are tangent to the surface. So the normal direction is perpendicular to both these vectors. And the amazing thing is that we actually have a tool that will allow us to calculate what we get for the parallelogram with area these two sides and the vector being normal, and that's the cross product of these two vectors. So the cross product of these two vectors times ds dt is going to give us the normal direction, and the size of that vector will be the area of the parallelogram with those vectors d sigma dt and d sigma ds as its sides. And that's what we can use for integration on a parameterized surface. Here is a closer look at the parallelogram that is formed from the parameterization. So this vector is d sigma ds scaled by the change in s. This vector here is d sigma dt scaled by the change in t. And the vector that's perpendicular to both these vectors and has area, that's the area of this parallelogram, is the cross product of this whole thing with this whole thing, the cross product of these two vectors.